In this video we will learn how to plot normal density curve. So let x be a random variable which follows normal distribution. So x is normally distributed, and a normal distribution, as we know, that it has two parameters. First one is the mean and second one is the variance. So generally this is written as x is normal with mean mu and variance sigma square. Then the probability density function or PDF of this random variable x is given by f of x is equal to, or p of x is equal to 1 over square root 2 pi sigma e raised to power minus half into x minus mu over sigma whole square, where this small x ranges between minus infinity and plus infinity, and mu and sigma square. This mu and sigma square, they are constants, and they are fixed. Any constant, they can take any constant value, but sigma, as we know that this is standard deviation, so it can never be negative. But mu can be negative, can be positive, it can take any value. So question is how to plot this density function. So first is that in the first column I have put the x, and x takes values from minus 5 to plus 5. And then in the next column, this is f of x or p of x. So this gives us the probabilities or the value of function when x, let's say take minus x takes value minus 5, then what will be the value of function? And then when x is this second value minus 4, replacing this x by minus 4, we will get another value. So this table is actually giving us the density values, the corresponding probabilities corresponding to each value of x. When x is minus 5, the probability is this one, which is almost 0, and then when x is minus 4, this is 0.000133, and so on. So how to plot this density? The idea is very simple. We need to focus on this these two parameters, mu and sigma square. So let's fix mu at 0 and st or sigma equals to 1. Please note that the second argument here is the sigma square, which is the variance, not the standard deviation, and standard deviation is square root of variance. So let's fix this sigma or standard deviation equal to 1 and mean equal to mean or mu equal to 0. So now in this column it actually gives us this formula is actually translated via some Excel command here, and that I am going to explain shortly that how it works. So before starting this, so here are few tips. So for the pi, generally the Excel command is equal sign pi, and then the open parenthesis and close parenthesis, and then this e is also mathematical constant, this one, this e, and this pi is mathematical constant 22 over 7 3.1415, and now e is constant, and e is the command, Excel command is equal sign and then exp for exponential, and within parenthesis represents its power. So e of 1 exp within parenthesis 1 means it is just e, or e raised to power 1. If we want to calculate e square, e raised to power 2, then this is actually equals, just put an equal sign and then exp and within parenthesis 2. So this will give us e raised to power 2, and the alternative command is, since this is e, we can simply cross check it by taking square of this. So use this cat sign as a power operator, or exponential, or taking power of e8, whatever is contained in cell e8, so raised to power 2. So 2.71 raised to power 2 is same as this e square. So you can see that this is just to cross check that you can use either this formula exp and within parenthesis 2, or you can simply calculate first e and then taking its power 2. Then similarly e cube is exp of 3, or we can verify it by taking the third power of this expression. And now if let's say we want to calculate e raised to power minus 2, the idea is same, exp and within parenthesis minus 2. Why this minus 2? Because here this whole thing is occurring in the power of e and with a negative sign. So that's why these commands were necessary to proceed further. And then pi is just pi pi, and then the two parentheses as well, and the e, constant e, is exp of 1. And of course this square root operator is, suppose we want to find square root of 16, the command is sqrt. So start with an equal sign and then type sqrt and within parenthesis 16. So this will give us square root of 16. So this is how this sqrt command works. So now coming to this cell, so I'm just deleting all the entries and I'm redoing it one more time. So look at this expression. It is 2 raised to 2 multiply with pi. So 2 steric for multiplication and then pi. So this gives us this pi 3.1415 multiply with 2. So if you cross check it, it is just the double of this. So 6.28. Now what we need to do, we need to calculate square root of this 2 pi. So in order to calculate square root of square root, so sqrt and then put this whole thing within the parenthesis. So we are telling Excel that take square root of this 2 times pi. So this will complete this expression, square root of 2 pi. And then this whole thing is being multiplied by with this sigma, where sigma is fixed at 1. So then steric and then use this sigma which is located in cell G1. So we have calculated this denominator. Now this first part of the expression is 1 divided by this. So what I'm going to do, I'm going to put here 1 at the start and then slash for division, and then this whole thing is coming in the denominator of this fraction. So in order to put this whole thing, we want that this expression, this highlighted expression, this should be evaluated first, and the result is actually the denominator of this expression. So what I'm going to do, I'm going to put a parenthesis here at the start and end. So this will calculate this denominator and 1 divided by this whole thing. If you press enter, so we actually obtained this expression. Now this whole thing is being multiplied by this e raised to power this expression. So simply click it here and then steric sign for the multiplication, and then we need to type this e is exp, and then the number is this whole thing that is occurring in the power of this as an exponent to this e. So it is minus 1 by 2. So minus 1 by 2, so you need to put minus sign, and then 1 by 2 is 0.5. So 1 divided by 2 is 0.5. So we have calculated this expression, and now this 0.5, this is being multiplied by this whole expression. So use the steric sign for multiplication, and then this parenthesis, and then x. This x is the first value of x. So I have used the address, cell address of this first value of x, which is minus 5, and it is located in column A, row 2, so it is A2. And then, so it is A2. And then this minus sign, so put minus here, and then this mu is located here in cell E1. So we have calculated x minus mu, and then we need to divide this whole thing, x minus mu, this difference, with sigma. So close the parenthesis. So this is x minus mu, and this parenthesis means we have calculated this expression, and now this expression is being divided by sigma. So what you need to do is put slash and then sigma here. So now we have this expression, x minus mu over sigma. X is located in A2, the first value of x, which is minus 5, minus mu is located in cell E1, whole over sigma, which is located in cell G1. So once we have this expression in our hand, then we need to take square of this whole thing, x minus mu over sigma whole square. In order to take square of this highlighted portion, add one more parenthesis at the start and close it here. So we have enclosed this whole thing within parenthesis, and now we want to take square of this whole expression. So put power sign and then 2. So this actually completes this x minus mu our sigma whole square, and then this whole thing is being multiplied with minus 1 by 2 or minus 0.5. So this parenthesis must be closed at the end. So that's it. So this whole thing is being multiplied by this minus 1 by 2 or minus 0.5, and we have put this whole expression as an exponent to this constant e. That's it. So once you are done with this, press enter, you will get this result. Now what I'm going to do, I'm going to copy this formula to the rest of the rows. So what will happen, this A2 will change to A3, which is minus 4, and then A4, A5 and so on, due to relative cell referencing. But we don't want to change this cell in G1 and this cell, the value in G1, the cell G1, and this mean which is located in cell E1. So we need to fix them by putting a dollar sign. Note that E is the name of the column, which is called column heading. So dollar before column heading, and this dollar before row heading, row number 1. And similarly you need to fix this sigma as well. So and this G as well, which is sigma. That's it. So what we did, we have used here absolute cell referencing. We are fixing this cell and the mean as well, and again the sigma as well, because mu and sigma, they are fixed, but we have not used the dollar sign with A2. A2 is the first value of x, that is taken as minus 5. So now when we will copy this command down to this row, the next row, then due to relative cell referencing, this A2 will change to A3, which is minus 4. While due to these dollar signs, G1 and E1, they will remain fixed. So this formula will be calculated for the same value of mean 0 and sigma equal to 1. And then we will copy it further down for x is equal to minus 3, which is located in A4. So that's it. Press enter. So this is the value, and now copy it one cell down, and now cross check it. You can see that it is still G1, the same sigma, the same mean E1, but now A2 is changed to this new value A3. That's it. So next double click it. So for a cross check, you can see that now this is A4 and the last value is A12. So this is how we complete this, and in order to get the density plot, select both columns. The x and the next column gives us the corresponding probabilities. So go to insert and this chart, and use this connected chart with smooth lines and markers. So here is the bell-shaped curve. So this is how you can plot the density function. Now some additional points that can be noted here are, look at the peak of this distribution. The peak of the distribution is occurring at value 0, which is the mean in our case. So this is the property of normal distribution, that highest probability of this normal density curve always occurs at its mean, which is 0 in our case. And this sigma, the standard deviation, it gives the spread. So now let's change this mean. Let's change this mean from 0 to say 1 and press enter. So now you can see that this peak got shifted from 0 to now it got shifted to this 1. So you can see this Excel tooltip, it is giving the x coordinate 0 and y coordinate 0.93. So if you change this to 2, so now you can see that the peak got shifted at 2 when x is equal to 2. whereas the rest of the shape is exactly the same, it remains same. So now change the mean back to 0. We got the same normal density curve with peak at 0, and now change the mean at -1. So now the peak got shifted at x is equal to -1, then change it to -2, the peak got shifted at -2. This property of normal distribution is called translation property. Translation means it is being translated at a particular value of mean. Now in this current case mean is -2, the shape is exactly the same, the only thing is that it got translated either horizontally, rightward or leftward horizontally. So now -2, then -1, then 0, +1, +2, and even you can play with other values of x, +3, +4, and so on, -3 and -4 and so on. So now change the mean back to 0. So this is the normal density curve, again with the mean 0 and sigma 1. Now let's play with this sigma. Sigma is currently taken as 1. Let's change this sigma to 0.5, 1/2. So reduce the sigma by 1/2 from 1 to 0.5. So now you can see that the shape of the distribution got shrunk. So this means that the variance or spread got minimized now. So do what? Change it back to 1. This is the original curve with mean 0 and sigma 1, and now change it to increase this sigma from 1 to 1.5. So now we are extending the variance. Press enter. Now you can see the spread got increased. So this is how the normal distribution works, and mean and variance, these are called two parameters of this normal density curve, and that's why this is the general notation that mean and variance, they are the parameters and they control all the characteristics, all the properties of the shape of the normal density curve. So this is all about the normal distribution, plotting the normal distribution and seeing how this normal density behaves when we change mean or we change standard deviation or the variance. Thank you.